Roger Proctor. He is Director of the E-Marine Information Infrastructure for IMOS and Director of the Australian Ocean Data Network. He's a firm believer in collaborative e-research and is a member of the NECDAR board, the US IUS Data Management and Communications Steering Committee. What else do you want me to read out? And an advisory member on 2 European projects on data interoperability.
Good morning. Welcome back after tea. Excellent. I'd like to talk to you this morning about MARVL and MARVLIS. As you'll see, MARVL is a virtual laboratory, and for that, where do I point this? It switched on. Oh, here we go. Yeah, and for those who've been asleep for the last week, then the virtual laboratories, which are run by the part of the Nectar program, and this is just pinched straight off the Nectar page, so you can see what the virtual laboratories are aiming to try and do. And in this context, then MARVL is aiming to make a community tool for ocean and coastal model forecasting studies and hindcast studies. Now, what if it doesn't work? Be back in a second. Flip to the next slide. Oh. So what we're trying to do here is to try and sort out a system whereby we provide a tool for accelerating any ocean model studies that you actually want to do. Thank you. And if you're a modeler, then these are the process studies, steps you have to go through in the system to actually get to the point where you can actually do some science with your model. And if you're trying to run a hindcast of storm surge forecasting or storm surge analysis, say, or environmental impact assessment of the effect of some construction that's being built somewhere, or you want to look at how physics or biology are interacting in a marine park area, there's a whole range of things you have to do, and these are the things that are listed on here. And what we're trying to do with MARVL is actually to condense those processes, which typically take of the order of 4 to 6 months, generally speaking, to put the information together that you need before you can actually start doing your work. So we want to reduce this time down to quite a significantly smaller fraction to allow more time to actually get on with developing knowledge and doing the research. So who will benefit from this process? Well, we think there's a range of people here who will benefit from the existence of MARVL, not just researchers who are actively involved in putting this thing together, but also it can become a useful tool for undergraduate teaching, for postgraduate studies, marine managers looking at how you can use these systems to sort of manage processes in marine parks, and consultants. MARVL is based on the thing called ROAM, this ROAM framework, which is the relocatable ocean atmosphere model system, which was developed under the Blue Link program, which is the CSIRO Bureau of Meteorology and Navy project. And the picture here shows you a screenshot from the ROAM interface as it is. And you can see here that you have an area here where you're going to immediately be able to throw a grid over a small domain that you're interested in having some information about. Through various parameters, you can set this thing running. You can actually see the specifications of what you're doing here, and say, as an example here of throwing a grid over the Southeast Australia region. Through the process, you can see what you've done before, and you can find out what's happening to the run that you're doing at the moment. And so this is something that's been set up for the Navy, so they can do tactical decision-making anywhere in the world. So what ROAM does is it runs on a desktop. It allows users to configure a region and time window. It allows you to select some hydrodynamics or surface wave simulation and provides a short-term forecast from these fixed data streams from the Bureau. And it's used by the Navy, as I said, for tactical support. What it doesn't do is it doesn't offer you a range of different models to choose from. It doesn't offer you options for initialization or boundary conditions. And at the moment, it doesn't really run hindcasts. It's configured to run forecasts only. And, of course, it's only available to a select few. So what we're trying to do is pull this out of this environment, make it something which is more publicly available to the community. And this will now enable us to do a number of different things. To enable efficient configuration of a range of different community models, both which are used in Australia, but which can be imported from outside those models which are freely available open source codes. So that will enable us to do efficient model intercomparisons and allow some assessment of the sensitivity of models to different model parameterizations. We're looking to make sure that it has some capability to deliver ensemble forecasting, which will help us quantify the uncertainty in model simulations. And through this, how we're integrating models and observations, that will enable us to do evaluations of the quality of the model simulations. And at some point, we'll be thinking about linking it in so you can do downscaling of climate scale simulations. And offering a set of options as to how you use this system. In the first instance, which is the early initiative activity of MARVL, we're looking at being able to assemble all the different data sets, configuration files, and actually wrap them up, and you can take them away and use it on a machine of your choice somewhere. As MARVL develops in stage 2, then we'll be looking to have this integrated into the cloud and also integrated into grid computing components. So you can just press a button and away it will go. And through HANS, who funded a top-up project on top of MARVL for the MARVLIS component I'll talk about later, this is an opportunity to bring together research data from observations and models and actually try and generate some added value products on top of this system, which are used to other groups in terms of decision making. And you'll see what I'm talking about in a minute. MARVL, of course, by definition, will be open source and it will be browser based. So in this stage process, the early initiative which we're involved in now, this is transforming the Roam components to become browser based instead of desktop based, and it uses the current configuration, which is the hydrodynamic model from CSIRO, SHOCK, and the open source coastal wave model, SWAN. And what we're doing now is embedding the data search capability that we've developed under IMOS and the Australian Ocean Data Network into this system, so that when you've defined your region and your time period, then you can, and parameters perhaps that you're interested in getting information about, you can fire off a request to the AODN data network to actually retrieve the data in the region and time period of interest. As a starting point for this, we're going to demonstrate its ability to work in southeast Tasmania. And as I said, it will provide this takeaway bundle of activity. In terms of connectivity between the MARVL framework and Australian Ocean Data Network, this will be done through web service requests. And at the moment, we're looking at building into this tool, Ramada, which comes from Unidata, to actually as a content management system, which will provide this machine-to-machine interface. So what is the AODN? It's a distributed network of Australian marine data and resources. Started off with IMOS, but was really the vision of this Australian Ocean Data Centre joint facility, which are the 6 Commonwealth agencies which are listed here. And it's grown since then to include data from state governments, from other NCRIS programs like Atlas of Living Australia and Terrestrial Ecosystem Research Network. And we're bringing into this program national program data sets like the National Environment Research Program, bringing all the marine biodiversity data from that program into the AODN. And there's a web address there for you to go and have a look at. So why are we choosing southeast Tasmania as our basis for our early activity demonstrator? Well, for some very obvious reasons, I think. It's quite close to home, Hobart, where we all live. And it's got an extensive observational program already. There's the Derwent Estuary program. There are university activities in there. CSIRO does some other things in this region. And there's a whole new program opening up in the near future. This program here, SenseT, which is all about integrating all sensor information in the Tasmanian region together to actually have a single space where you can discover sensor data from Tasmania. There's also a quasi-operational modelling program underway, which is linked into this other group here, INFORM-D, which is all about using science to support management in the region. And the region has quite significant issues. There's a lot of aquaculture facilities going on in this region here, Don Tricasto Channel, which is this bit here. And in the upper Derwent region, there's a lot of marine sampling, which is routine monitoring done by the local environment agency. And so what we're actually thinking about doing is addressing two questions which are pertinent in the region. One is to do with public health, and the other is to do with aquaculture management. So we started this process now. We have a MARVL portal, and for any region within the domain of the model that's running at the moment, you can actually throw a grid over that region and then do a higher resolution calculation within this space. And you can select a whole range of things like salinity, temperature, and the like. And you can then send that off to find out what data overlaps with the period of choice that you're interested in. And then you can do things like start the simulation, etc., etc. In the second stage of this, which we're in negotiations at the moment, of course, we're going to increase the range of models available to be used in the system. We're going to increase the options available for initialization. And we're going to demonstrate the cost benefit in 6 regional applications of the system. And then, let's say, I'll provide these extra facilities to run in the cloud and run through grid computing. So it's MARVL's a bit like this, the configuration. You specify a whole bunch of stuff as inputs. There's a set of generic configurations, of course, which you'd expect. And then there's a data extractor and regridder, which goes and gets all the necessary data sets, including the observations. Then it either becomes a takeaway bundle, or then it goes to one of these 2 options down here. So these are our 6 test regions that we're working on. We have bureaus involved in running a Tasman Sea simulations using MARVL. The University of New South Wales is looking at solitary islands systems, running regional ocean modelling system and Wave Watch 3 and Swan. South Australia, there's one down here for South Australian shells. UWA is looking at aspects over the Perth Canyon. Ningaloo Reef up here through CSIRO, and Australian Institute for Marine Science is running simulations in Darwin Harbour and Beagle Gulf. And that overlaps very nicely with some of the observational data sets that we've collected through IMOS. The information system, which is funded by ANS, is really looking to do a number of things here. Generate data collection for the Derwent, which is something that hasn't been done before, which is to put all this information together and publish this through ANS Data Commons, and to develop data products from the underlying observational model data to address these 2 aspects, public health and ecosystem health. So in essence, what we're trying to do is separate between real-time, short-term information and information influencing the longer-term state, and try and contribute to the state of the Derwent assessments, which routinely happen, and end up in a book about this thick. So if we're talking about beach watch, this is how currently information about beach water quality is provided to the population of Tasmania. It's in this form, which gets published in the local newspaper. And it looks like that, and it's hardly readable in its form, let alone what the information is telling you. But all it tells you really is what's the long-term state of these particular beaches, and what's happened in this last week. And the way they put this together is it's a weekly chart in the summer. It's published on Saturday, but it's based on measurements of enterococci taken on a Tuesday. And this takes no account of environmental factors which happen between Tuesday and Saturday. And we know very well that rainfall affects the quality of the system. Yeah. So we're developing an interface which will allow us to actually bring up all the different status of the beaches which are around the region. So if you click on a particular beach, you can download all the information about how it is today, how it's been in the last few weeks, and some information about why it's changing. We're also, as part of this process, looking at risk assessment, and in that we're going to integrating Connie 2 for risk assessment, which you heard about yesterday through Scott Condy and the James Tizard Prize. And this is a way of looking at dispersion properties in the estuary and then assigning some probability of occurrence to these things. So the benefits we see of MARVL is that it adds a library of system enhancements of MARVLIS to MARVL to enable decision making, and it will therefore go wherever MARVL goes. And we're working closely scientifically with a whole bunch of science people to ensure that this is a lasting information system. So in summary, 2 points. MARVL provides a framework for model observation studies, and MARVLIS provides value-added tools for exploiting these data sets. Thank you.
Thank you very much, Roger. Has anyone got any questions for Roger? Surely someone has one.
Excellent.
Don't run away. Roger?
Yep.
So could you all join me in thanking Roger for the very good... That wasn't meant to happen. You're not ready to start until... Another 5 minutes.
They left 5 minutes.
About 5 minutes. So I'm sure nobody wants to ask Roger a question. I don't go away for a murder. Roger, you've got a question.
So the data, the algorithms, they're not so data intensive. Why would you also do that?
I think it depends on the scale of the system that we're trying to do. I mean, we're going to do the model, you can go through all kinds of very high resolution and
the data.
Can you, sorry, could you go to the, please use the microphone? You please use this microphone.
Hey, Tim, see what's going to happen to you next, can't you?
They're under control. Right, go ahead.
All right, and the second question, the data that when you're using the cloud, the data that you're getting is sort of temporary data that you just download from another source, put it on the cloud node, process it, and display the result, or what sort of persistent data?
Yeah, well, we're looking to try and do so that the data is persistent because it's part of the Australian Ocean Data Network, so that's freely available to anybody to use at any time. So that the system will issue a request to the Ocean Data Network for particular data in a particular region during a particular time window. Then we're looking to actually be able to return that data for one of two reasons. Either as a validation, so maybe a time series comparison at a point, say, but also to look at a way in which we can reassemble that data so it can become part of a data assimilation scheme. And that data then is held for the duration of the simulation.
The main data that you have on the cloud, though, is this sort of temporal stuff, and the original data is coming from another repository.
Yes.
Kaylee Waterford from Intersect. When you say the MARVLIS will be looking at 6 regions,
yep.
Is that only because you've got 6 good data sets at the moment, or could you uptake on more regions as time goes, or you need a finite group to?
Well, the answer is yes and yes, I think.
Yeah.
So we chose these 6 because all of the groups are actively already involved in IMOS one way or another.
Yep.
And so they're already familiar with the processes and the scientific questions that were being addressed in those regions. And the second part of that is we're open to anybody who wants to get involved in this process, but we just can't give you any money.
Excellent, thank you.
Okay, well, thank you, Roger. They were a bit slow to get going with the questions, but thank you very much.